Hello and welcome to today's Climate Match Academy keynote. We'll be talking about futures from the frontiers of climate science. What is it that we can expect from climate change in the future? And how might we change energy and food systems specifically to cope with these changes and also reduce the emission trajectories that we're on and reduce the impacts of climate change in the future? These are really important plots from the IPCC. These are called burning ember diagrams. And we can see the different burning ember diagrams for different risks for the assessment reports over time. So we can see the 2001 burning ember for aggregate impacts. These are impacts to the economy and ecology. And then we can see it for 2009, 2014, and 2022. And what these show is that the impacts on the economy and ecology that we thought would hit at 3 degrees of warming in 2001 are actually now forecast for 1.5 degrees of warming. We're thoroughly in the danger zone today. So there's been this systematic underestimation of how fast these climate impacts could hit societies around the world. We see the same thing for large-scale discontinuities. These are changes like Greenland ice sheet loss or the changes in large-scale ocean currents. And we can see that these also have come down time and time again through the years. This systemic underestimation of the impacts of climate change on the big systems around the world is kind of a bit surprising, because if we look at the modelling for temperature, for example, it's been incredibly accurate. So scientists have been able to tell pretty much exactly how warm the planet would get for a given amount of CO2 and other greenhouse gases in the atmosphere. It's been really, really accurate. So this systemic underestimation over time is a real quandary. It's also one of the reasons why we've moved from 2 degrees, talking about 2 degrees of warming as a target, to 1.5 degrees. This was one of the major reasons why we had that shift not so long ago, within the last decade. So let's have a look at an example about why this is so very hard to understand, so very hard to model. Let's look at the boreal forests in the higher latitudes in, say, Canada or Siberia. What we're seeing is that as the world warms, the pests are moving further north too. And so pine bark beetles are just having a field day eating through trees. They're eating through trees, they're killing them, they're leaving this fuel in their wake. And what we're finding that also as the world warms, lightning strikes, the ignition source for wildfires, are also moving further north. So this warming world, these lightning strikes are moving north too. And of course, this is a recipe for disaster. You have the fuel, you have the ignition source, you have all of this rich carbon, high carbon forests, and we're seeing record wildfires due to it. Now, this is just one example, but it's a combination of biology, meteorology, climate. It's a lot of different disciplines, and you can imagine how hard that is to model. It's also hard to model because a lot of the data that we have, especially the high resolution data, are from sort of recent decades, and we're moving into a very unprecedented climate system, unprecedented extreme weather events. So the models that we're using and the parameters that we use in those models from the observations that we have may not apply to a world that's moving so quickly and so far out of equilibrium. What does this mean, though, for communities around the world? So, these systems are changing. What does this mean for communities? One paper had a look at all the different, sort of the overwhelming number of words here, all the different ways climate can impact society. And they found over 400 different pathways. Now, this is a bit overwhelming, so let's have a look at an example here. We can imagine how water scarcity really affects communities very directly, of course, because we all need water. But it's also the most important way to deal with temperature increases in agriculture. So we need water for irrigation. And if we don't have it, we see yield losses. You can imagine then malnutrition from that. Because people are then hungry or they don't have enough nutrients, you can start to see a vicious cycle where people also get more disease because their immune systems are suppressed. Then we can see society hit these stressing points, these tipping points, where societies can't cope anymore, communities can't cope anymore, and we start to see displacement, migration, violence and conflict. The most recent IPCC report said that the evidence of these observed impacts, projected risks, they demonstrate that worldwide climate resilient development action is more urgent than previously assessed in Assessment Report 5. So not only have we systematically underestimated how fast climate change can hit us, but we're also less resilient than previously assessed also. So we've got sort of this combination of these two nasty effects. And the result is what this looks like. It looks like extreme weather events around the world, often hitting the poorest hardest and first, because within nations and across nations. Now, there's a lot of arguments about whether this is numbing, whether this numbs people. And you're really interested in climate change, so, perhaps you've seen this a lot and you've engaged in this a lot. But I think it's worthwhile showing these images because we're still not connecting climate change with extreme weather events in the media. Have a think about the number of times you see reporting, say, on a drought or a heat wave, and you see children eating ice creams or playing in fountains, instead of, say, people struggling to keep cool in their homes and potentially even dying in their homes, and reducing the reduction of yields from agriculture, the drought on the fields, for example. We can see here the words in media articles in 2020 for the UK and Nigeria. And yes, it was an important year for COVID, but climate change is an existential threat to civilization. It is not hyperbole to state that what happens with our efforts to address climate change in the next 10, 20 years will impact what's happening on the planet in thousands of years, and potentially will have impacts on the planet in millions of years, because if the impacts on biodiversity loss, for example. What we can see here is that climate change, despite being this incredibly unique and worrying existential threat, is mentioned less than dogs in the UK. It's mentioned less than football, politics, the Queen. We're not connecting those images that I just showed and this scientific information with the media and connecting to the general public. Now, that's all sort of quite negative, and we're seeing sort of big impacts on food systems already. The chance of multi-bread basket failure, where we see 10% reductions in multiple bread baskets around the world, cereal crops around the world, goes up dramatically to 1.5 degrees and even more at 2 degrees. And this is all very scary. But let's have a look at the historical emissions and some work that we did recently. So we can see these historical emissions in black here. And we can see our projected statistical assessment in red. And what we're doing there is we're taking into account the efforts made to reduce emissions so far. And we can see that we're starting to actually avoid some of the worst case scenarios that the IPCC could come up with. Perhaps even the second worst and the third worst scenarios that scientists have come up with to model in the IPCC. The problem with this, of course, is that the middle of the road scenarios are now a disaster. So yes, it is absolutely true that we have likely avoided the emission trajectories for the worst case scenarios, but we may not have avoided the impacts of those scenarios. And it certainly looks like at the moment there are many areas around the world tracing the worst case scenarios, even though we're not on the worst case emission trajectories. And ultimately, we need to be on this 1.5 degree trajectory, and we're miles off it. So it's completely insufficient. But the point that I'm trying to make here is that even with this insufficient effort, we have had some agency. There has been a reduction in emissions compared to where we thought they may go. And so it shows that humanity, or that humans or cultures and societies around the world can make an impact on emissions and change the future. So it's late in the day. What do we need in order to reduce the emissions, especially in high emitting countries? Let's remember that the highest burden must fall on those people and those communities, those countries that have emitted the most emissions historically. And we're talking mainly here about energy and food transitions. Now, we need economic transformations in order to enable some of these things, but I'll focus on the very practical side of what has to happen in the energy system, what has to happen in the food system to reduce these emissions. Let's talk about the energy system first. The energy transition has basically been made possible through the dramatic reduction in wind and solar energy costs over time. They have dropped incredibly, faster than anybody thought possible. So the solar costs here we can see in 2009 have dropped from way up here high in the graph down to below gas and coal generation by 2020, and they're continuing to drop. In recent years, it's flattened off a little bit. There may, with some of the materials, it impacts maybe sort of a slight increase, but we're still doing a lot of knowledge gathering. New technologies are coming out all the time. And it is still the case today that it is cheaper to install new solar and wind power than to continue to operate existing coal and gas in many areas around the world. And that's kind of amazing. And you may say, why haven't we seen that then? Why haven't we seen all the coal power plants being mothballed and wind and solar panels being put up? And partly it's due to the fact that this takes time, infrastructure takes time, and I'll talk about some of the blocks in a moment. But it's also because in many countries, coal and gas are politically protected, and so they are encouraged to run, they are subsidized to run. And so we need to address some of those dynamics too. If we look at all the different types of energy types, anything that can be electrified, so electric vehicles, electric heating, for example, is going to be easy to electrify, easy to decarbonize, because we can produce that electricity with wind and solar. And we can see the segments here that are attached to one another, those are easy to decarbonize. The only areas that are hard to decarbonize now still are long distance transport, like aviation and shipping, industry, some industrial materials like iron, steel and cement, and load following electricity that shifts electricity across seasons. We can already flatten out the demand, the sort of energy during the day and night, but moving it from, say, the summer when we may have lots of energy to heating homes in the winter, or vice versa, that's more difficult still. The point being here that well over 70%, 75%, even we're moving from 70 even to sort of 80%, even higher, is easy to decarbonize with wind and solar. It's easy to decarbonize with the technologies we have. And this is an important point. We actually have the technologies for all these other areas also. We do have those technologies. It's just that they're quite expensive at the moment. And so this is not showing the pie. The segments that are further out from the pie chart are showing things that are impossible. They're just showing things that are expensive at the moment. One study, very recent study, looked at the costs of a fast transition compared to no transition. And this takes all the costs of the entire energy system transition. So all of the pie chart that you saw before. And what they found was a fast transition is cheaper than no transition by $12 trillion worldwide. And they found that a faster transition is cheaper than a slow transition. So a transition by 2050 is cheaper than a transition by 2070. And this is on economic costs alone. This is not even including air pollution costs that kill millions each year. It's not including the geopolitical costs of having to buy expensive oil and gas. So really, it's not a question of economics. It's not even a question of technology anymore. It's a question of speed. How fast can we make these changes? And that really comes down to social issues. Social issues like permitting. Can we get the regulations and the permitting in place to install the renewables, to install other energy types that we may use? Transmission. Can we install the transmission lines to help balance out the grid? If you have more wind here than solar there, vice versa. How do we transmit this energy? Every single paper you look at suggests that transmission is a no-regret scenario, but it takes permitting to build. It takes time to build. Making sure that markets are integrated and energy systems are integrated so we can make the best use of the materials. A good example here is some work that we did where we found that electric vehicle batteries alone could satisfy short-term grid storage demand by as early as 2030. And what that would mean is you wouldn't have to then build extra stationary storage for the grid to balance out the daily fluctuation in wind and solar. The last 10 to 20% is hard to decarbonize, so that is going to have more investment. And so that will require, but again, the most important parts, the biggest bulk of the technologies that we need, wind and solar, electrification, that's the vast majority that we need. Labour requirements, we're going to need lots of people to be working on this. And material requirements. You often hear that, yes, okay, it might be cheaper. Yes, okay, it's healthier for us to have healthier air, for example, but we don't have the materials for it. Well, we've done some work here too, and perhaps pause the slide here and you can have a look at this figure. But what we find is that even during the peak of the rollout of the energy transition, the amount of material that we mine is almost half what we were mining for coal in 2021, for example. So that's an astonishing reduction, and we do that once. With coal systems, you extract the coal, you put it in the power plant, it burns. We put that stuff into the atmosphere that ultimately it stresses societies, kills people, and in this case, we're extracting these materials, putting it into a system that then is a asset in society. And then if we can make that circular, if we can make sure that we're recovering those materials as much as possible, then we can reduce the amount of materials. Now, I also think we should reduce the amount of materials that we need overall, and we should reduce our energy footprints and how much energy we need as well. And I am very aware that some of these developments may impact different communities around the world in different ways, and we need to do this really carefully. But some of these talking points about material requirements are just a way to slow down and not even have that conversation. But do we really want to continue digging up coal, for example, which is just much, much worse? Even if we have an energy system transition, the food system on its own is enough to push us beyond 1.5 or even 2 degrees, those emissions, even if you were to decarbonize the energy used for food. And that's from deforestation, that's from land use change and these sorts of other emission sources. So what we need also is a great food transition. And this study looked at the emissions per year in 2050, given current trends, and where we would need to get to by 2050 as a target. And they found that the food system transition is made up of 3 things: plant-rich diets, reducing food waste, and improving production. And that's shown in numerous studies. Every single study shows that plant-rich diets have the biggest opportunity because animal agriculture is by far the largest producer of emissions from the food system, especially in high-income nations. It's around 75 to 80% of all emissions from the food system comes from animal agriculture. And because animal agriculture really takes up an awful lot of space too, we had a look at what would happen in high-income nations if people ate a plant-rich diet. So not a completely vegan diet, but a healthy diet, a diet that was built by nutritionists, by medical doctors, also with the planet in mind. That would be sort of the healthiest diet that people could follow. And that's you can cut out all animal products in that diet. They gave a range, but we used a middle point where we said, okay, we'll take the middle point of this diet, and that was something about like a hamburger every 2 weeks or so. That was sort of the level of the meat consumption in it. And what we found is if these high-income nations ate these diets, we'd save an area the size of the EU. Now imagine if we could then help farmers spare that land, pay them to draw down carbon, to rewild that land. We would have a huge carbon sink. We would draw down carbon from the atmosphere. And what we found is we would double the impacts of just the emission reductions from the changes of the diets alone. So that's an incredible opportunity. And let's just think about what this might look like. Here we have 2 figures of pastures, and we can see there's not a lot of vegetation there. There's not a lot of other wildlife. It's a bit of a biological desert, really. I mean, there's soil erosion. These are not good lands for coping with flooding, for example. And let's compare that to more rewilded lands where we've got native fauna, native flora, more carbon storage on that land, and more ability to absorb the punches of climate change, the floods, the storms. This land is more resilient generally than the pastures that we see on the left. It also means more access to nature for everyone who sort of lives near these regions, and that has huge impacts on health. We know that being in nature improves our health dramatically, even though perhaps we don't get out for walks enough like we should. Now that's energy and food transitions, and really they're visions for the future that are quite wonderful, I think, because we're talking cleaner air, cleaner water. We're talking lower inflation because we're not buying fossil fuels from the market anymore. We're building cheaper energy systems for the long run, insulating our homes, being more comfortable in them, etc., etc., etc. It's a really, really lovely vision for the future. Even if we didn't have to do that for climate change, we would probably want to do it because it would be better for all of us. It just so happens that we also address these huge existential issues of climate change. Here, though, I also want to point out that the emissions are not equal around the world. And we can see here on the left the emissions per person in the bottom for 50%, 40%, 10 to 1%, and the top 1%. We can see how much higher the top 1% emissions are, and even the top 10% emissions are to the middle 40%. And on the right, I've shown what would happen if these top level emissions would come down over 10 years. Where would that get us in terms of our trajectories from current policies all the way down to the 1.5 degree scenario? Let's play this forward. What we can see is that a 30% reduction in the top 1% alone would reach our 2030 targets. So that's quite remarkable. Now, if we take the top 10% in total down to the average EU footprint, which is, I would argue not a bad life at the average EU citizen, we almost get on that 1.5 degree scenario by addressing inequality on its own. Now, that's quite remarkable. That's without any energy transition or food transition, just reducing the amount of consumption there. Now, some of those emissions are coming from investments, so I should caveat this that it's just kind of an overview of quite how large these emissions are and what the kind of opportunity is there, and that it's quite it could be quite difficult to bring some of those emissions down if they're investments in, say, machinery or buildings or companies, these sorts of things. But you can see the scope for change there. So then the question is okay, if it's cheaper, it's better for us, we've got this lovely vision, do people want this change? This is a wonderful, wonderful study that looked at 6,000 people across the US, and they asked them, do you think other people would support a carbon tax? Do you think they are worried about climate change? Do you think we should have 100% renewable energy by 2035? And people assessed what other people thought they said they would support. Then they asked those same people, do you support it? Do you support a carbon tax? And this is where they ended up. The actual support for these different policies is much, much higher than everybody else thinks it is. So there's this false social reality, as they called it. I would say we're far too cynical of our neighbours. A carbon tax, which is one of the most controversial policies in the US, the prevalence of support that people thought was about 32%. In reality, is like 67%. That's an incredible jump. And that was true across Republicans, Democrats, lots of different political ideologies. And so then how fast can people change, say, adopting a new habit? On the left here, we can see the size of a committed minority. And as that size of the committed minority goes up, we get more adoption across the majority group. And so as we start to hit 10% here, we start to see some increases. And then as we hit somewhere around 25%, we often see this tipping point in society where the minority convention is adopted by the majority. You can think about things like smoking, gay marriage, these sorts of issues, which have also seen these tipping points over time. You can think also about dietary change, for example. On the right here, we can see protests and marches and a tipping point there. We can also see a massive increase in the number of court cases related to climate change. So these are really good feedbacks everywhere. These are feedbacks because in technology, the faster the investments pour in, we learn more, we bring the costs down. Solar panels, we're doing like smart phones. We're learning how to do them so much more quickly than these big hulking power stations that we don't get these opportunities to learn with. Then the faster the costs come down, then the faster the better technologies outcompete. In society and behaviour, the faster we make small steps, the further steps become easier, and the faster change becomes. We know that as there's been more and more interest in plant-rich diets, that in canteens that have started to offer more plant-rich options, even the meat eaters eat them because they sound exciting. And this is not a story of abstinence, because there's tens of thousands of edible plants out there, and often we don't eat, say, more than 20, 30 plants in a week. So it's a story of exploration, not of abstinence. It's not saying cut something out. It's saying, no, we're going to have some really exciting, really interesting food coming in the future. And civil action, more lawsuit and more actions means that the documents that are discovered through those lawsuits can be used by other legal, other sort of NGOs to bring even more legal cases to bear. And the faster the change becomes. So these are huge feedbacks everywhere, and they're interacting together. So often this sort of feels very overwhelming. It's a lot of information. We often get kind of overwhelmed at what we can do as individuals. I'd like to really sort of simplify this down. Don't sweat the small stuff. It really is not a big deal where your tomatoes come from. It's not something you should worry about in the supermarket. If you're going towards plant-rich diets, then that is by far and away the biggest impact you can have. Equally with plastics, yes, it's a different important environmental issue, but it pales in comparison to some of these other issues that you face when you're making choices in the supermarket. So if you're reducing animal products, and especially beef and dairy, then you're doing really a massive change. And these 5 changes or choices can make a huge impact to both climate and biodiversity problems. I would estimate that they would address around 70% of climate and biodiversity. I mean, if you could fix any problem, the 60 to 70% of that problem with 5 choices, I think you'd do that, wouldn't you? And of course, it would make a better world. So going renewable, electrifying your life, we've heard this already, going plant-based, getting engaged, both within work, within your family, within your friends, and getting talking with them about, yes, the problems we're facing, but also the hopeful future. And don't be a purist. Don't kick yourself. Take small steps and see. Do you like those steps? Do they feel good to you? Then take another step. Take the easiest step first. And then you'll see how easy some of these changes can be. And climate conversations and social contagion, that means systems change. So as you get solar panels, research shows that the rest of the neighborhood is more likely to get solar panels too, for example. And encourage others to get involved. Some of the biggest things we can do in work to impact a systems change is to take personal action and to talk about it. Research shows that we get more credibility by talking about the actions that we've taken. So for example, reducing flying or even cutting out flying. They got to a point where I couldn't do it anymore. So about 6 years ago, I stopped flying completely. And, that's not to shame anybody. It's just that I couldn't deal with it anymore. But then it's important to talk about it and let people know. Equally, if you move towards a plant-based diet, research shows that talking about it opens up other people's opportunities to engage in plant-based diets. And even by giving a lecture about plant-based diets, researchers found that even 3 years later, they saw changes in people's diets due to it. So we have agency. Although all of the things that I mentioned at the start are very worrying and scary, we do have agency to change the world. Engage in your different networks, families, friends. Be creative about thinking about who you can talk to about this hopeful vision. That was a picture of me talking to MPs in the UK, for example. Civil protest. Think about joining and supporting. You don't have to do direct action. You can just be there to support those people who are doing the direct action. For example, on the right there, a colleague put lots of posters of academic papers on a water cannon, and we were having a little poster session. Now, of course, this is very different in different countries. Different countries have different options for protest. And so please do be really careful and do research what the laws are in your country. Support younger generations. They will be the people who are moving into the jobs and making change in the future. And look for openings. Be creative. Don't beat yourself up. This is a little bit like what I mentioned before. Don't sweat the small stuff. And try to find ways to align work with addressing climate change, because we're all very busy, and it's often really important to make sure that you're doing multiple things at the same time. So I would like to leave it there. This is the last slide. And we live in this incredibly unique time in history. Human society has never faced something like this, where the many of the things that underlie the infrastructure of our world, energy and food, are actually driving us to an existential threat for our communities around the world. Nobody's saying that humans won't be around, but our societies may not be able to cope with these impacts. So how do we communicate in this world? I would say we need to be honest. We do have to talk about where we're going. We can't just blindly close our eyes to it, because often, that feeling of being alarmed is quite natural. And that is the internal tipping point that pushes a lot of people for change. But at the same stage, we can't leave it there, because if we just alarm people and walk away, then that can be very debilitating too. So we have to give a vision of the future that is better than the one that we're currently on, the trajectory that we're currently on. Show a pathway to that future. I've just shown you the energy and food system transitions that we need. Those are the pathways. And then act towards those pathways. And interestingly, that's what hope looks like. Giving a vision, showing a pathway, and then acting. That's what philosophers, Habermas, Hannah Arendt, they all talk about. You have to have a vision for the future, show that pathway to get there, and have some agency over getting there. And some of the ideas that I've given you, I hope, will make you feel like you can have agency in getting there too. The IPCC put this really well. Every action matters, every bit of warming matters, every year matters, and every choice absolutely matters. No matter how bad things get, every choice matters. Your engagement and action matters. This is obviously a lot of information, some from recent research, some from other people's research. I have a whole book on this, looking at paired chapters of pessimism and hope to really show and distinguish the difference between the trajectory we're on and this wonderful vision, this better vision for the future. So if you'd like to check that out, please give it a look. Okay, all the best for today. I hope the rest of the course goes fantastically.